Okay, today in Math 20-1, we're looking at Chapter 6, Topic 6.3, Adding and Subtracting Rational Expressions. Well, let's just review a little bit. To add fractions that have the same denominators, you just add the numerators. 5 over b minus 3 over b would be 2 over b, and b cannot equal 0. 1 over 7 plus 3 over 7 would be 4 over 7. 7a over 3b minus 2a over 3b would be 5a over 3b. And again, b cannot equal 0. Now the next one is a little tricky. 2a minus a minus 1 means you're going to have 2a minus an a, but then you're also going to have a minus 1, which becomes plus 1. And then our final answer would be 2a minus a is 1a plus 1 over b, and b cannot equal 0. In the next one, we have 2x over x plus 4 plus 8 over x plus 4, and that'll be 2x plus 8 over x plus 4. But we're not done, because we can factor a 2 out of the top to make it 2 times x plus 4 over x plus 4, and the x plus 4s will cancel to leave you with 2, and x cannot equal negative 4. In the last one, we have x squared plus 3x minus 10 over x minus 2. That can be factored because we can find two numbers that are going to multiply together to give you negative 10 and add up to the middle term of 3, and that has to be x plus 5 times x minus 2. The minus 2's, x minus 2's are going to cancel, and we're left with x plus 5. X cannot equal 2. Let's continue with adding and subtracting rational expressions, except this time we're going to have different denominators. So when the denominators aren't the same, we're going to make them the same. When we have 2 over 12 plus 1 over 18, a common denominator would be 36. Therefore, we can say the lowest common denominator is 36. Now I've got to change both these fractions so that they'll be over 36. In the first case, I'm going to say 12 times 3 is 36. The top is 2 times 3, which is 6. The bottom, the next one, 18 times 2 is 36. 1 times 2 is 2. And that'll add up to 8 over 36, which reduces to 2 over 9. In the next one, what we have to do before we can find a common denominator is to factor what we already have. I have 3x minus 12 as one of my denominators, so I'm going to factor a 3 out of that. So now I get 10 over 3 times x minus 4 minus 3 over x minus 4. Now, to make these denominators the same, I can times the fraction on the right by 3 in the denominator. That way, both denominators will say 3 times x minus 4. But if I times the bottom by 3, I got to times the top by 3. Now I can say the top is going to be 10 minus 9 over the bottom of 3 times x minus 4. And that simply is going to be 1 over 3 times x minus 4, and x cannot equal 4 is our answer. And C, we have 3 over x squared minus 9 plus 4 over x squared minus 6x plus 9. If we follow the steps on the right, we have to factor the denominators. 3 over x plus 3 times x minus 3 plus 4 over x minus 3 times x minus 3. Now, in order to make both of these denominators the same, I have to look and I can see that the first one has an x plus 3 and an x minus 3 on the bottom. The second one has two x minus 3's. Now, to make them the same, I'd have to add another x minus 3 to the bottom of the first one, And I'd have to add an x plus 3 to the bottom of the second one. Now I can say my common denominator is going to be x minus 3 times x plus 3 times x minus 3. The top now in both of those fractions. If I multiply the bottom by x minus 3 in the first fraction, I have to multiply the top by x minus 3. The second fraction was x plus 3, so I've got to multiply the top by x plus 3. And so now I'm going to get 3 times x plus minus 3 plus 4 times x plus 3 for the numerator. I can clean that up, expand it, 3x plus minus 9 plus 4x plus 12 over my denominator. And now I'll just simply clean it up. 3x plus 4x gives me 7x plus 3 over x plus 3 times x minus 3 times x minus 3. And that's our answer. We have to say as well that x cannot equal positive or negative 3. On our last slide, we have example 2, and subtracting the following rationals with unlike denominators. Always simplify, always state any non-permissible values. Now 2x over xy plus 4 over x squared minus 3. I'm going to think of that bottom as not x squared, but x times x. That way it'll enable us to see a little bit better what we have to do. So 2x over x times y plus 4 over x times x minus 3 over 1. I have to multiply that first fraction by another x on the bottom and an x on the top. The second fraction, I have to times y to the bottom and y to the top. And the third one, I got to multiply xy to the bottom and xy to the top. Now I've got a common denominator of x squared y for all three fractions. Now I can simplify the numerators to get 2x squared plus 4y minus 3x squared y. And since all of the numerators are unlike terms, we're done. Except to say that x cannot equal 0 and y cannot equal 0. In the next one, we have y squared minus 20 over y squared minus 4. Well, the y squared minus 4, of course, we can factor that to y plus 2 times y minus 2. We're going to add to that y minus 2 over y plus 2. And now in order to make it the same, I got to multiply the bottom by y minus 2, and therefore the top by y minus 2. Now I have a common denominator of y plus 2 times y minus 2. The top's going to become y squared minus 20 plus another y squared minus 4y plus 4. And when I clean everything up and add the numerators together, I'm going to get 2y squared minus 4y minus 16 over y plus 2 times y minus 2. I'm going to factor a 2 out of that. And then I can factor the y squared minus 2y minus 8 into two binomials, which will be y minus 4 times y plus 2. Now I can cancel the y plus 2's to get a final answer of 2 times y minus 4 over y minus 2, and y cannot equal positive or negative 2. Last one. I have x of 1 plus 1 over x on the top, x minus 1 over x on the bottom. I'm going to find a common denominator. The common denominator for the top would be x. So instead of expressing 1, I'm expressing it as x over x plus 1 over x. And the bottom, I have x minus 1 over x. If I take that x and I multiply the top and the bottom of that by an x, I'm going to get x squared over x minus 1 over x. Now I'm going to simplify that to be x plus 1 over x divided by x squared minus 1 over x. But before I do that, I just want to explain how I've got to that position. On the top, 1 plus 1 over x is 1 over 1 plus 1 over x, and then I can times the top and the bottom by an x to get x over x plus 1 over x. The bottom, x over 1 minus 1 over x, means I'm going to multiply the top and the bottom by x to get x squared minus 1 all over x. So back over on the right side, x plus 1 over x divided by x squared minus 1 over x means I'm going to multiply by the reciprocal, and that means I'm going to get x plus 1 over x times x over x squared minus 1. The x's can cancel, and I'll end up with x plus 1 over x squared minus 1. And now I've got a difference of squares on the bottom. I get x plus 1 times x plus 1 times x minus 1. And the x plus 1's can cancel, leaving me with 1 over x minus 1. X, of course, cannot equal positive or negative 1 or 0. For your homework tonight, I want you to do page 336, numbers 1, 5, 6, 7, 8, and 10.